Welcome everybody. The countdown is on. The show has started. Welcome back after lunch. I hope you enjoyed the lunch break and the tech showcase. My name is Lars Morowski-Bre. I will talk to you today at length about building reliable Ceph cluster with SUSE Enterprise Storage. I apologize for the long name. That's basically based on our real-life experience that we've seen with customer deployments, internal deployments, and the questions we usually get associated with them. I've been doing Ceph for about 4 or 5 years in this role now, way before SUSE even officially had a dedicated Ceph project. Before that, I've been focused on high availability, on our clustering solution, on our HA stack. Been with SUSE for almost 17 years now. And frankly speaking, quite a number of the concepts between HA clustering and reliable storage solutions on software-defined storage actually transfer pretty nicely. So hopefully I have some idea of what I'm talking about. If not, we have a bunch of engineers in the room who will be more than happy to correct me. They usually are. Let's go in. So what is this talk not about? So I'm not going to be doing a comprehensive introduction to Ceph. Right? This is not a Ceph technology primer. I will review some parts of the architecture because they are relevant to, how to build a dependable system. It's also not a roadmap session. I will not talk about specific features unless they relate to availability and dependability of the system. And it's also not a discussion of Ceph performance tuning. Here I'm really focusing on the non-functional aspects of dependability. Of course, performance is a question that also comes up in that context, and how to maintain your required level of performance through failures. But it's not the main focus. And what I also should have put on here, this is not a sales pitch. So I'm not trying to sell you on Ceph. I'm not trying to sell you on software-defined storage. I'm trying to address the questions that come up in the context of building dependable software-defined storage solutions, right? And if that ends up with you wanting to deploy a Ceph solution, that's absolutely great. I would be delighted. If this ends up with you going with a traditional HA failover solution, I'm also delighted, as long as it all runs less, of course. So that said, this is not an introduction, but there are some ideas that I would like to cover. So SUSE Enterprise Storage, what is that actually? Ceph. SUSE Enterprise Storage is at its core a Ceph distribution with management and orchestration added. Ceph is this open source software-defined storage project that's been gaining a lot of attention recently. You may have heard of it. It's the primary use case for cloud storage, most popular OpenStack storage backend in the world, and it gives you a lot of front-end access protocols, right? You have object storage, you have block I/O, you have iSCSI on top of that. We now have CephFS. Eventually we'll have production grades, NFS re-export, you have low-level interfaces, and you have all those things. And this is all built on top of a common smart data store, right? Which smartly distributes and redistributes your data in your cluster and across the nodes. What does this actually look like? What does software-defined storage mean, right? So take a bunch of CPUs, a little bit of memory, a bunch of network cards, a lot of disks or SSDs, some network switches, and just a tiny little bit of power, right? You add the right ingredients. Obviously, you would add SUSE, you add OpenMatic for management, and of course, this is all built on Ceph. And you get this perfectly scalable, wonderful thing that gives you files, block storage, cloud storage, and containers, right? That's all there is, right? Does it blend? Yes, it does, right? And at the end of the day, of course, it turns out that the devil is in the details. If I was a salesperson, I could stop here. Unfortunately, I'm not. Or maybe in the interest of the company, it's better that I'm not. Taking a look at the logical view, just because we want to be talking about this. So the core is actually this RADOS layer, the common object storage in the back end, where the OSDs, the object storage devices that actually manage each individual disk live. The monitors, which coordinate which OSDs are up or down, and OSDs also coordinate amongst each other. You have metadata servers for Cephfs. If you're using any of the gateways, you have the Rados gateway, which is the S3 and Swift protocol. You have iSCSI gateways, probably for redundancy, multiple ones. And you may have NFS gateways as well if you're already playing with SUSE Enterprise Storage 4 as part of the beta program, right? So this is, at its core, it's a distributed software that aggregates storage and transforms it into storage that your applications can consume. So it's built on top of Node local storage, which is also an important distinction, and we'll go back to how those components relate. So I will not talk a lot about the individual features of those components, but it's really important to understand that under what supposedly is this very simple software-defined storage thing, that this software thing is actually fairly flexible and breaks out into a lot of components, and I didn't even draw all the Linux daemons that tie into this, right? So, and what do I actually mean when I say dependability, right? Dependability is ultimately you can divide it up into several categories, right? But it's not about performance, it's about availability, that your service is actually up and running and reachable. It's about reliability, so that's actually providing correct service. And in the context of storage, you also have the concept of durability. So how long is your data alive? How much faults can occur before you actually lose data, right? And safety, which we are not going to talk about a lot here, basically what happens in case this thing breaks down. Is there, is the failure mode safe? And maintainability, which is also important because if your system is not maintainable, you will likely introduce failures as part of your story. And then your system is no longer available, which has the CEO calling you at 3 AM, calling the salesperson, ringing me. So let's try to avoid this. But you probably came here to learn about technology, and that's actually what I will be talking the most about. But there's an elephant in the room. And actually the elephant in the room is all of us. What do you think causes most of the outages? Of course, it's the engineers. It's always our fault. That's true, because we should have made the software so that it's impossible to misconfigure. But at the end of the day, it's your people. If this is, I have only very few slides at that high level, but really it's the people. It's the processes. You're already here to improve that, right? But it's training, which is what you're getting here, what your people are getting here. It's documentation, which is what we are also delivering, but it's also about the documentation you write about your own system. A Ceph cluster is hopefully very long-lived, and it's maybe 3 or 5 years down the line, somebody will want to know why you did something a certain way, and it would be really awesome if they could still find the documentation. If you're anything like we are internally, by that point in time, you've moved wikis 5 times, and it will be kind of hard to find. So that's also important to keep in mind. But of course, we can help you, right? You're not alone. So a lot of what I'm going to show in the next slides is a lot of things to take in, not all of which may apply to your situation, but we are here to help. Right? So there's a world-class support organization at SUSE and also with our partners. We have partners like Novacoast, Hastexo, HPE, obviously, all IBM, all those people have consulting organizations, support organizations that can help you. So we are glad to not leave you alone. So that said, let's move in. You came here to learn about technology and not to be told that you should buy training, so let's get into the technology. Let's first look, if you have looked at any of the environments out there, day 0, what do you start with, right? You get this reference architecture. All your nodes are identical, right? If you look at any reference architecture, all the nodes are identical. That's wonderful. It eases system administration. The components are interchangeable. You have lower purchasing costs because instead of buying 10 different servers, you buy 100 of each. Right? And you have a standardized ordering process, right? That's great. For day 0, day 1, this is how you start. What could possibly go wrong, right? So let's take a look at Murphy's Law 2016 version. At scale, everything fails, right? So distributed systems, clustering systems protect against failure by eliminating single points of failure, right? You don't have a single failure of anything taking down your servers, right? You have multiple nodes, and single node fails, it really, at the end of the day, doesn't matter. The rest of the nodes continue to take on the service, right? So, and that's great. That actually works. I've spent 15 years of my life doing that. It's really great. But there's a problem. Distributed systems have one problem. They're vulnerable to correlated failures, right? And with a lot of the things we're going to look at will help you understand what correlated failures actually are. But at the very high level, it's a monoculture, right? If you imagine this field of, corn, and you have this one bug they are all susceptible to, they all die at the same time, right? Literally. So, at the end of the day, everything is broken, right? So, you will say, yeah, well, but if I replace that has this other, failure mode, and that's true. But everything is broken differently. That is a big secret, right? Hopefully, we all hope. We have some customers that go to great lengths to avoid being exposed to correlated failures because they are required by law. And frankly, you will have to make your own call when you stop being paranoid. I'm a very paranoid person. I'm an engineer. I always worry about things going wrong. It's sort of like my thing. But yeah, so you can benefit from this. And actually, if you look at day 2 of your system, right, you have built it. Your life cycle starts ticking. It's a Ceph cluster. It never goes away. You keep adding capacity, I hope. And in 3 years, you're no longer going to be buying the same server you bought today, unless that hardware vendor really stuck you with an impressive contract. So hardware changes, right? The hardware you buy changes. The drives, definitely in 3 years, the drives you're going to buy are different, right? Have you ever bought the same hardware drive for 3 years in a row? I haven't. Or the architecture you're stuck with is simply no longer, yeah, you can buy it, it's just too expensive, right? Software updates are not globally immediate, so you may have some configuration drift, and we'll get to that. And requirements change, right? So the system you've built today, probably 3 years down the line, you will have to have some storage that's faster, some storage that's denser. So this whole idea of having the single, unique, unified hardware pool where all the nodes are the same, I believe in political term, it's called an election promise. Your cluster will end up being heterogeneous anyway, and you might as well benefit from it, right? So there are benefits to this. Of course, there are scenarios where you absolutely don't want to be exposed to this, but in terms of hardware, there may be benefits. So, and there's also this other thing, right? Failure is unavoidable. Suffering is optional, as the saying goes. But if you really want to have uptime, you need to prepare for those failures, right? You need to look at it and not just go, yeah, those systems are not going to fail. You need to prepare for it, and you need to take into account what failures mean and how they arise, right? So you architect your system to survive a single or multiple failures, and you test whether your system meets your service level agreements. And, frankly, test this not just while everything is up and running, test this continuously, and test it especially while you have pulled a node and while the system is recovering. Because, as I said, at scale, everything fails, and mostly systems tend to fail under load, right? And that's exactly when you need to meet your SLAs. So you need to architect your system so that you have excess capacity that you can still satisfy your users while it's recovering. You can also, of course, limit the bandwidth Ceph uses for recovery, but at the end of the day, you also want the recovery to be finished eventually, right? So you have to take this into account as part of your sizing. So over-provision. High availability is all about having redundancy. It's not about having a system that just barely scrapes by, okay? And that, I have some more specific appointments on the next slide, but this already brings me to the next point. There ain't no such thing as a free lunch, right? You have a trade-off between availability and durability and cost complexity, as you could already see when you go like, yeah, your reference architecture really should include hardware from 5 vendors. Complexity that not everyone needs, right? I'm just putting this out here for you to think about. Some of the things are easier than others, but you have to make your own call. How paranoid do you need to be to meet your business requirements? That is a point that I can't answer in this presentation. That's a point that we have to answer in one-on-one conversations, right? And actually, the good thing is scale-out makes some things easier. If you have 1,000 nodes anyway, buy them in batches of 500 or 300, right? There's some flexibility there. And now, after those high-level considerations, I would like to take the first, if you have any questions, just, wave at me, shout at me, and I will repeat the question. So at any time, feel free to go ahead. So the next slides I have really dig into the suggestions on all the levels of what you may want to look at. And that's something that I already mentioned. So embrace diversity. And we'll, again, go back to more specific examples. But when you look at what a system needs, right, if you want it to automatically recover, it needs to be able to make a tie-breaking choice. That means, actually today that's really easy to explain. You need more than 50% of the systems to vote, right? And there's actually distributed system theory. If you want to be able to handle certain kinds of failures, you need to at least have more than 50% of the vote. Certain failures require essentially 66% to, if you have a malicious attacker, but mostly you're assuming you need to be able to break ties, and that requires 50% majority. And that actually already brings you to the point where having two different kinds of devices, for example, may not be enough. Because if you have two different kinds of devices, and one of them completely goes down, you end up with 50%. 50% is not more than 50%. It's exactly 50%. That means the system cannot automatically determine which side is right. You lack the tie-breaking vote, right? So actually breaking it into systems that automatically achieve more than 50% is hard for some components, and it's easier for others, right? If you have 3 monitors, we'll get to that. Having 3 monitors on different hardware is reasonably easy. Splitting your OSDs, the storage devices, into chunks of 33% exactly each is kind of hard, right? And actually, there's this interesting thing. You may look at multiple architectures. If you have Intel hardware exclusively, some of the bugs may, and actually we have customers that worry about these things, right? If you're running a really reliable system, you start worrying about these things that are affected by failures of the Intel CPUs. They mix different kinds of Intel CPUs, and nowadays they are looking at mixing that with ARM CPUs in the same distributed system, and our software can do that, right? We support ARM and Intel, and you can mix that because the network protocols are identical. And yes, of course, you don't want to have all those systems then grouped. Okay, this is my rack of Intel servers, and this is my rack of ARM servers, because then, one of those racks goes down, and you suddenly lose all that diversity, which you also don't want. And even if the system isn't automatically available to recover, if you have something where you can go in and manually cast that tie-breaking vote, saying, okay, continue. Yes, you lost 50%, but the data is still there. You're no longer automatically available, but you are reliable and durable. You haven't lost the data. You can manually go in and continue, right? So you have to have a trade-off there. And to help you with choosing the right kind of hardware, we have reference architectures, right? Even taking into account that I've said that you may want to mix up hardware vendors, you may also not want that because it really complicates your architecture. We have a lot of reference architectures. We have partners that offer turnkey solutions that help with the choice of hardware. Because hardware choice is hard. The promise of software-defined storage is that you can go out and buy any hardware you want from that supplier down the street, or Amazon, Alibaba, eBay, and we'll have it work, right? And that's true. We'll make it work. If it runs less, we'll make it work. But it turns out that small variations in hardware can already have a huge impact, right? We've had customers that were like, I went with your reference architecture, but I bought a network interface card that was $10 cheaper per card. And it's a newer model, right? So it will be great. And we spent the next 3 months debugging firmware bugs together with Intel and the switch manufacturer, because it turns out that it wasn't. SLES wasn't even at fault, but small variations like that in complicated systems, they interlock. And if that's not factored into your timeline, then that delays your production start. The system is up and running beautiful today, but the customer would probably have wanted to avoid that. And so we have a yes certification that reduces risk, and you may have missed that as part of our keynote announcement, but we actually announced that we are extending that software certification for cloud and storage customers, and the SUSE Ready certification that tests more parts of the hardware environment so systems can self-certify. So that's also something to take into account. You know, by all means, go out and buy that hardware. We'll help you making it work. There's still safety. You know, we reduce complexity by reference architectures and turnkey solutions. And again, like I already said, don't put all your servers into one rack, right? Otherwise, that rack goes down, and you suddenly lost your entire cluster. So you may want to distribute it across multiple nodes, multiple rooms in your data center, multiple racks, multiple rows, so you're not affected by correlated physical failure. Like that one sprinkler that suddenly goes off and melts your entire rack. Thankfully, none of our customers has experienced that before, but it has been known to happen, right? You may want to have some distance between your servers, different fire barriers, and so on. So that pretty much goes without saying, but if you're doing software-defined storage for the first time, maybe you haven't had that on your radar before, because there's so much flexibility that you get to choose how paranoid you want to be. And the next question then is, okay, so I have all this much hardware. How many monitors do I need? So I was trying to not have a slide with too many words and a lot of text explaining that. 1, 2, 3. So for most of our customers, 3 monitors is the right number. If you're doing a proof of concept, a really small environment where you don't have any hardware at all, yeah, you can run 1 monitor. If it's a pilot, we do that on our development systems. You do want it to be an odd number. You don't want to have 2 mons, right? Because otherwise you go like, one is down, does the other one can't, you hit that 50-50 split. You want to be in situations, or not to be in situations where you have a 50-50 split. So 4 monitors is also reasonably pointless. You want to go 3, 5, 7, and Joe, has there ever been a case where somebody had more than 7 monitors for a good reason? Okay, right, so yeah, so 3 monitors and split them across your availability zones, right? 3 availability zones, if you are going down that route, tends to be a good number. Right. Next slide. And then the question is, do you want to converge functions on one piece of hardware, right? So do you want to have the monitor running on one of your OSD nodes? And to that, the answer is it depends. I have a hoodie that just has that printed on it, because it always depends. If you mix roles on the same piece of hardware, obviously you're correlating failures, right? That hardware goes down, you just lost 2 pieces. Now, on the other hand, it does drive down the cost of implementation, and if you otherwise couldn't afford the system, it probably is worth doing, right? Sizing becomes less deterministic, because those systems also would likely want to consume more memory at pretty much the same time, namely during cluster recovery phases, right? So you have to, add all that excess memory, and that's fine, but at that point in time, memory, when you figure all that in, you might as well have added a 1U server. But if you have a small environment, it's probably fine because your recovery is also not going to use a lot of additional memory. If you're going to 100 nodes, don't correlate. At scale, separate especially the mons away. You can always have gateways on the OSDs, you can for scale-out purposes, but the mons are really a good thing to have on separate hardware, right? That's basically it. And again, this is a common theme. The scale at which you operate really determines some of your choices and how paranoid you need to be. Going back to that paranoia, what kind of yes, we have a question?
Sorry, just regarding the mons. So, would you recommend rather have mons as a virtual machine on other hardware rather than combine together?
Okay, so the question was whether it would make sense to have the mons as virtual machines or running on the OSDs as physical hardware. If your OSD nodes have enough resources, I would probably prefer to not run them on VMs, but on the physical machines. When we look at that in the long term, we probably will end up with all those Ceph services containerized, and then there will be this monitor container on the OSDs as well. So at that point in time, the overhead and the additional layers and complexity goes down. I think we have had environments where the customer had 2 availability zones, and then they needed that tiebreaker, and they put one of the mons on a VM in a separate room, right? That there's no real reason that stops you from doing that. But in general, Ceph really wants to run on as close to the metal as possible because we give you storage. You really want bandwidth, right? So, okay. Right, storage diversity, right? At the top level, avoid desktop components, right? Both for SSDs and hard drives, desktop components are annoying. They lie about their caching behavior. They are not reliable. Desktops have this tendency to hang when they have an I/O error because the drive retries. Enterprise firmware will typically bubble up the error sooner, so giving the operating system above a chance to recover. And desktop SSDs in particular also have worse lifespan. When you use SSDs in a Ceph environment, particularly as journals, all writes get funneled through that journal, right? That means they see all the writes. You're only using maybe 5 GB of the SSD per drive, but it's still using all the writes. So, you're wearing them out really quickly for desktop SSDs. That's not a good thing, and your life expectancy goes down. And we have seen SSDs that started out beautifully in some of our reference architectures, right? They started out really well, and a week to 2 weeks in, their performance was cut into half, right? Because the wear leveling kicked in, and they slowed down. So you really want enterprise SSDs for the journals, because enterprise hardware is simply more honest about the specs. And just the general things, I've been bitten by that in my own rate, which is why I'm always including it. Avoid sequential hard drive numbers, right? When you're bulk ordering from a hard drive vendor, you're going to get hard drive 1, 2, 3 with sequential sequence number. Guess when those things are going to fail? On day 1, on day 2, and on day 3 of each other. It's a thing. I swear to God, it's a thing, right? And you actually may want to, if you're really paranoid, you mount some of them in this angle and some of them in this angle, because sometimes your data center shakes. Because somebody operates a power drill next to it, which they shouldn't have done, but have done, right? So I've not hit that in the Ceph environment yet, but I've hit that in the HA world, because then all your drives bounce that direction, and some of the drives bounce that direction, and maybe some survive. It's a thing, right? So the real world is unbelievable. And of course, you may also want, if you can still find them, you may want to look at having hardware from multiple vendors. Simply because they have, again, different failure modes, different firmware bugs, different hardware problems. Diversity is a good thing. And hard drives are a pretty easy way to bring in diversity because they are pretty interchangeable anyway, right? Having different kinds of hard drives is not a big deal, and it's a good method to avoid problems. Next thing then is how many hard drives do you want to stick into a single server, so storage node sizing. Right next after drive failures and administrative failures that bring down the entire cluster at once, the common unit of failure tends to be the single node, right? Because kernel crashes are a thing, power failures are a thing, exploded CPUs are a thing. Well, no, it was the capacitors that explode and CPUs just melt. It happens. So at that point in time, you want to consider the impact of an outage on performance and capacity. So when you lose a single node, you obviously lose all the storage attached to it, right? And that's not good, right? So you not just lose the storage, you may have to reconstruct it. And then you have, maybe if you have only 4 nodes, our minimum supported configuration is 4 nodes, which makes customers sometimes believe that 4 nodes is the recommended size, which it is not really. So Ceph is a scale-out solution. You get more reliability, more scale-out, more redundancy, more diversity by having more nodes, right? A general guideline that I would recommend to strive for is a single node should not have more than 10% of your total capacity. And another thing to keep in mind is that it's not just the performance and capacity you lose, but also you have to possibly then reconstruct one of those 500 terabyte monster nodes, which probably in 2 years will only be 3 drives. But you have to reconstruct that through that single network pipe that they're all sitting behind, right? So smaller nodes are better, right? And also give you more performance per capacity. Because with Ceph, as you add spindles, you add also bandwidth, because every spindle, every node comes with its own network pipe. So, and this is also an important thing to watch for. The free capacity you have should not be lower than the capacity of your largest node, as the used capacity, because you lose that node, the cluster is trying to reconstruct from the degraded mode and rebuild the mirrors, and suddenly you're full, right? And if you have 4 nodes, a single node constitutes 25% of your capacity. So in total, you have to overspec every node by 25% to be able to handle at least a single node failure, which you really want to handle. So again, it becomes easier if you scale out your nodes. That's pretty clear, right? When I say redundancy, what do I mean by that? So Ceph has 2 principal modes of protecting your data and replicating it. The first one is the traditional RAID 1 mode. It just maintains individual copies of data. And the second one is called erasure coding, where you get to choose basically how many chunks of data have how many parity chunks. So that gives you a very flexible way of affecting the overhead. I have slides to explain that a little bit more. But essentially, it amounts to you have linear overhead with replication. If you have 2 copies, right, you have a usable capacity of 50% because you're, right? And you typically have 3 copies because you want to be able to handle something like 1 node down and an additional disk failure, right? So that means you need 3 copies because that might be the disk holding your data. So, and that gives you a pretty bad, you know, capacity impact. Erasure coding then has more like a fractional overhead, and when you look at the slides, or even when you Google SUSE Ceph erasure coding, you'll find this YouTube video from last year's SUSECON where that is actually more visually explained, and I'm going to spare you watching it in this presentation. So just to illustrate that, here you have like 3-way replication. You have 1 master copy and 2 individual copies that are identical, and yeah. That basically means your usable capacity has just dropped to 33% of your gross capacity. And you can only withstand 2 faults, right? Advantage of this is it's pretty damn fast because replicating the same data is pretty good, but you also have a huge capacity impact, right? Next thing would be 4+3 erasure coding, where you have your data block, you chop it into 4 pieces, and then you compute 3 additional parity chunks. And that means you have a usable capacity in this example of 57%, which is a lot better. And at the same time, you can withstand 3 faults instead of 2. You have lower overhead while getting better durability, right? You can't use this in all scenarios because erasure-coded pools currently are somewhat feature-limited. You can't directly use them with CephFS, for example, or with block.io. But if you do object storage, maybe erasure coding is something you actually want because it gives you much better density and more durability. So in the typical sales pitches, we emphasize this aspect, density, because it drives down your cost. But I'm trying to sell you on durability so that you can, and you can play with these. You can also have like 10 chunks with 4 parity chunks that gives you a 50% overhead while being able to withstand 3 outages. That's pretty neat. The downside is you want these distributed across several nodes. So if you have 4 plus 3 equals 7, you want at least 7 nodes to be able to actually distribute those individual chunks across multiple nodes. So nothing is free, right? Again, this is one of the examples where scale-out solutions really benefit from simply having more nodes so they can distribute out the data better. And that brings us to cache tiering, which is awesome. Cache tiering for some scenarios has great benefits, but the cache tier is typically replicated. The cache tier in front is meant as an accelerator, so it's replicated. And the backing tier typically is erasure coded. And that's typically a bit slower, but it's actually more durable. So when you have a lot of data sitting in your cache tier, it's actually more exposed to failures and outages than your backing tier. So you may want to play with these parameters and keep that in mind. And when you actually want to calculate the overall availability of your system, I recommend you bring in master students of computer science. Because the probability math gets a little bit risky, but it's just something to keep in mind. You know, just to put that out there. So basically, different strokes for different pools. In Ceph, you can have multiple pools, which is a logical aggregation factor, and have different settings for different pools. You can have some pools in your system that are 3 times replicated. Maybe you have this scratch pool where you really only care about performance, but because it's scratch data that you can simply recompute, you have 1 copy of the data and you lose it and you go, okay, I have to recalculate 4 megabyte, whatever. Or you have multiple choices of erasure coding schemes. So there are some pyramid schemes where in erasure coding you need a lot of data traffic to reconstruct after an outage. And where that allows you to have additional chunks within the same rack, so you don't have to actually go to reload data from a different rack over the top of the rack switching infrastructure. So that is a little bit too complicated to explain in these slides, so I'm just putting that out there, and we can gladly discuss it after the talk, but there are different erasure coding schemes that have different advantages, especially at large scale. You know, for your typical cluster that lives in the same rack anyway, you probably don't care, but if you have a really big installation, you will. Also, data sometimes literally goes back because of cosmic radiation. It's a thing, I've seen it. Well, thing with cosmic radiation is that it's kind of hard to prove, but statistically, you have data going bad at all places in the caches, which again is one of the reasons why you don't want desktop drives, because the caches on those drives, guess where they are not using ECC memory? On the cache that funnels all your data to your drive, right? So what you eventually end up with is data that's inconsistent across the drives, right? And Ceph has a tool called scrubbing that detects this data, and then currently you have to manually go in and correct some of the errors. It will tell you that 1 copy of the data is bad, but it's not yet quite able to figure out which one, because it just sees, this data is not what I think it should be. So in SUSE Enterprise Storage 5, based on Ceph Luminous, BlueStore will have checksums on read, and at that point in time, I hope Ceph will be able to detect, well, I have 2 copies of the data with a good checksum, and 1 copy that doesn't match and has a bad checksum, but the checksum matches, I'm guessing this is wrong, right? So that's coming. So, and again, this is a periodic task. You may want to tune the impact of the deep scrub on your data and set it so that it matches your durability requirements while not impacting your performance in ways that you don't like. You should also test whether you meet performance of your system while a scrub is going on, right? Testing is a really big part of building dependable systems. And again, Ceph recovers automatically. That can be a good thing and a bad thing. If you have a cluster node going down and you're not quick enough to replace it, Ceph will start rebalancing and backfilling and reconstructing placement groups so that it goes from degraded to good, so that it has the required number of placement groups again. If you did that on purpose, well, because you're servicing that node, maybe you don't actually want to shuffle about a few hundred terabytes of data, right? So there are tuning options that you can set. Specifically the no out option, which means Ceph does not take that node out of the computation of the crush map. So that's just something to be aware of so that you can prevent unexpected impacts and rebalancing a lot of data. It's always a network that gets you, I already mentioned that. People, and that's another thing where diversity is actually quite possible because there are several network vendors. You can use network bonding because you obviously want redundancy on all your paths, and you may want to consider using different network interface vendors. And this is me being very conservative, which I usually am not, but the newest hardware is also the hardware with the newest drivers. That is not always a good thing. You may want to use hardware that's actually proven in the field, right? The good thing is hardware from last year is typically also a little bit cheaper. And if hardware from last year is more expensive than hardware from this year, maybe there's a reason. So yeah, so you may want to look into that. And when you then have different switches as well, because you're really probably paranoid, you may then want to actually connect the cards also, right? You wouldn't want to go all your say, your cluster backbone to go to that switch only, because otherwise you lose that switch and you still lost your entire cluster backbone, right? So you cross-link them. Also pretty straightforward. And this, I have this on here because the most annoying bugs that I've had to debug this year with the team was a network driver problem. So, and in that case, it was because all the cards were identical. We couldn't just simply tell the customer, yeah, okay, we know it's not optimal, but just disable this one card driver while we are debugging it, and you're still up and running on your redundant configuration. Isn't that great? So, and that's another thing, right? You should test what happens when you actually kill half of your network environment. Because if you have spec'd the system that you actually need the bonded bandwidth at max performance, you're not going to meet your service level requirements during an error, which from an availability point of view means your system is down during a recovery phase. Gateway considerations, again, single gateways are bad. That is obvious, right? If you have single gateway service, it goes down, you lost your service. You can, for a router's gateway, use Swift. You use an HTTP load balancer. For iSCSI, it's native to the protocol. You have multiple gateways. We added that. That's actually the big thing that we added to the iSCSI implementation in Ceph, is being able to have multi-pass gateways so you can scale out. And that improves both availability and throughput. And again, make sure that, you know, this is a recurring theme, that your system meets your performance requirements even during degraded modes. Okay, one question?
You mentioned earlier running the targets on the OSDs.
Right.
Is that what you recommend, or do you recommend having them set?
Okay, so the question is whether it's recommended to run the iSCSI gateways on the OSDs itself. That's perfectly feasible, and it's a pretty safe choice, especially when you're running a reasonably small configuration. Ultimately, when you run, say, 100,000 OSDs, you know, well, 100 or 1,000 OSD, man, I really want to talk to you. Then you probably don't want to present, say, 100,000 paths to your iSCSI EU clients, right? So at that level, you may want to limit it and run it on dedicated gateway nodes, but then the overhead is also marginal. There's not a huge advantage in Ceph because data locality isn't a thing. The data is randomly distributed anyway, so most likely all your network, all iSCSI traffic has to make one additional hop to go to the right OSD anyway. But for small environments, sure, it's perfectly feasible. And then if you have multiple, it's perfectly fine. Thank you. Good question. And now, moving a little bit up, configuration drift. This is a kind of diversity that you do not want, right? Different installed package versions, different installed packages themselves, right? Sometimes different repositories. I've seen, suddenly people add repositories from OpenSUSE to some of their SUSE Linux enterprise servers, and suddenly you pull in all those different versions that are, possibly not because nobody has tested them together before you did. So you really want to avoid configuration drift. Also, the same thing goes for passwords, logging, NTP, really important. Ceph distributed service, really sensitive to time, right? So, and that's something where we now ship tools that are really great at preventing this. Avoid manual configuration of each individual node. Right, we have Salt, that's our configuration management tool of choice. So this is a blog post introducing DeepC, which is a talk you missed this morning. At least I missed it because I was in another one, but it's recorded so you can go watch and see it. And also there's a fairly interesting thing that I found during my preparation for this talk, how you can manage configuration drift and rollback with Salt and Snapper. So Snapper is a snapshot application for SLES itself, and something goes wrong on an update, and you just tell Snapper to go back to the last update, to the last known good status. That's really cool, right? So something went wrong with your package update, just no deal, reboot and go back. Ultimately, that is something that we hope to achieve with containers and Kubernetes, right? There's this new silver bullet that makes every problem go away. But right now you can already do it. It requires currently a little bit of scripting, but it's there, right? So that's really something I would suggest you investigate, because whenever I do something manually, I may get it wrong. Maybe it's just me. And then trust but verify, also called monitoring. Monitor the performance as the system ages and fills up. I mentioned I'm not going to talk a lot about performance, but ultimately, eventually there comes a point where your performance drops to the point or below the threshold where users consider the system available, right? And you want to catch that before it happens. And as your system fills up, these are the things to watch out for. SSDs slow down as they age. It's not all of them, newer hardware reduces this. But again, that hardware hasn't been in operation for 5 years. So maybe you want to trust but verify, right? And as your capacity fills up, you actually you have less bandwidth per actually used terabyte of data, right? That is, yes, you have 10 gigabit per 100 terabyte gross, but when you actually start using it and get random access, you use more of that bandwidth possibly. You may also want to watch for that. And free bandwidth, free capacity, I already mentioned that you don't want to drop it too far, right? Just like on a root file system, if your root file system is at 95% utilization, you may want to delete some data, or in the Ceph case, you may want to just have ordered the node and just add it at that point, right? And once you find issues, you also obviously have to react to them in a timely fashion. That sort of goes without saying, right? And then updates. Updates are really important. Always update, but with care, right? Updates are generally good for your system. SUSE releases them because they fix bugs. They typically fix more bugs than they introduce regressions. Now, I'm not going to lie to you. Occasionally, they will introduce regressions. I'm not a salesperson. I'm allowed to say that, right? Because the diversity of the total environments out there is just too large. It's impossible for us to encounter every single issue, regardless of how intensely we test. It's not an expectation that's realistic. And we don't want you to be the one to hit that problem. If you're sticking to one of our recommended configurations, we probably tested that, right? That's good. The more diverse your environment, the more you deviate, the more you want to validate yourself, right? It's simply, and of course, they all fix security. Security is boring, performance boring, but they also fix stability. That is, that is important. So, yeah, and the good thing is Ceph allows you to remain available even while updates are being rolled out, because you can upgrade one node after the other and then end up with an upgraded system. And actually that's one of our main values of the maintenance subscription, is that we give you tested updates. So we tend to encounter a lot of bugs before we release, right? So if something actually, yes please?
With updates, you can update a node at a time. Has there ever been a situation where all of the nodes had to be simultaneously updated? There was no backward compatibility. Is that a concern?
So the question is if there's ever been a situation where you couldn't do rolling upgrades, right? That's
obviously coming up through the ranks,
right.
Early on.
Yes. Yes. So that's true. I mean, earlier on with the current versions, we will try really, really, really hard for that not to be required. If it is, and we notice, we'll inform you ahead of time. And if that ever goes through and you do get exposed to that, you can be sure that I have been hit on the head by my product manager for weeks before we made that call. But we really try to avoid this, because the overall idea is obviously that you can upgrade, that your cluster is never down, right? We try really hard. I can't promise for all of the future, but this is what we strive for. This is what we really, really hard strive for.
Is that even true through service pack updates as well?
Yes, you can roll forward through service. So you can roll forward through service pack updates. You can update one node after the other. There may eventually be at some point in the future points in time where we may have to. You can't always roll back. Let me put it that way. So once you have upgraded all the nodes, and at that point realize there's something you don't like, you may not always be able to roll back a single, you may not be able to roll back. Rollback is really hard. So once you have started to actually say convert to on-disk format, it's really hard to roll back. That's tricky. But our promise is that you will always be able to roll forward without taking the system down. Right. Yeah, so that's actually, so SUSE eats bugs, right? Chameleons, did you actually like that? Chameleons really like their bugs, and then less bugs. That's really, yeah, I had too much time. And again, trust nobody. And that's exactly why that question was so great, right? And you can really tell that I'm not a salesperson, right? Because you really don't want to even trust us. If you are running at scale, you want to have a staging system, right? You want to test our software in your specific environment with your features. And ideally, your production system is an exact copy of your, an exact copy of the system you're running. It's not always feasible, of course. You have to shrink it. But it should be representative, and nowadays there's really very little excuse for not having a virtualized testing environment. Just to go through the motions, test it yourself. The closer you are to our own recommended configurations, the less necessary this is. We literally have customers, very few of them, but they exist, that have all the systems they have out there with exactly the same hardware, maintained at exactly the firmware revisions they have in the field, in their lab, and test all our updates on that environment. I'm actually personally happy that they do that because I also fly through Frankfurt, and I'm very happy that the radar towers are very reliable. So I'm very happy they do that, but whenever they call me and tell me there's a bug, I go, yes, sir, we are fixing it, because they're always right. They have an internal thing where they have to pay pizza if they report a bug that is not a bug. So yeah, so that is a kind of diligence that's not required for everyone. But staging systems are really useful, just so that you can, especially if you have your own upgrade processes, right? Testing is the most important thing to improving dependability is testing, right? Not just the code, but also the processes. And of course, you came to the right place. Long-term maintainability, if you want to maintain your system, which you need to keep going, you want to avoid vendor lock-in, right? Obviously, I want you to believe and trust that SUSE is the best vendor. But if you use Ceph, it's technology that in CO you would be able to get from someone else, right? Obviously, I really don't want to. Yes, please?
Does that mean you can mix a Ceph cluster with nodes running SUSE, with nodes running Red Hat, Ubuntu, Fedora, whatever, Debian?
That is okay, so the question is, can you mix and match different Ceph and Linux distributions in the same cluster? And the answer to that has multiple aspects. Will any of the vendors support you with that cluster? The answer is no. Will any of the consulting organizations probably help you migrate from one vendor to the other and end up with a supported configuration that's based on one vendor's software products? The answer is probably yes. And would you actually want to do that? Probably also no. You wouldn't want to run that kind of diversity, because at the end of the day, they would all be running at pretty much the same code. So it wouldn't actually give you a lot of diversity in terms that matters, right? And it would give you a lot of headache from your system administration point of view. So yeah, you can migrate. And frankly, all the vendors have pretty clean upstream integrated versions of Ceph. So yes, the protocols are comparable. You can do such a migration, but you will. No, you can't run. You can technically. The answer is yes. You can do that. Practically, I doubt you want to. So, okay. Okay. So, and of course, there's this other taking final look. Disaster will strike. Eventually, something catastrophic will happen, right? The question is just when. Question is, does it matter? That's sometimes people over-prepare. If the disaster is that your office building burned down, maybe an offsite backup is just enough, because you really don't care that your service is up, right? It's a concern. We've had questions like that, and we're like, you're no longer in business when that happens, right? So it's a yeah, backups are, however, really important because something could happen to your cluster. Yes, please?
You talked about scaling, and I'm imagining a multi-petabyte Ceph cluster. How do you back it up in a fashion that it is still costs?
Okay, so yes, so the question is, how do you actually back up your Ceph cluster?
Do you need to back up all the data too?
Okay, the question is, do you need to back up all the data? And that's a question I cannot answer. The question, what data on your Ceph cluster you actually have to back up depends on which data you actually need after that cluster went down. So that depends on your business requirements.
Probably a different question. Using Ceph does not get rid of a traditional backup solution.
No, just like RAID is not a backup solution, Ceph is not a backup solution. It can be a backup target, it can be a backup source, but it does not, in all environments, replace backups. I'm sorry, I just want to, I'm watching the time, I just noticed, I have only two or three more slides, so I will just run you through, so sorry. We have a tool called RBD Mirror that allows you to replicate block devices, or Router's Gateway can also have a multi-site feature where you can replicate S3 and object storage protocols that may be necessary if you want to run disaster resilient configurations. And again, that's also something that you have to test, right? But short summary is you may still need backups depending on what your business goals are. So you actually, what it all boils down to is you want to avoid complexity, right? And that helpful acronym means keep it simple with SUSE, right? So it's not that other thing, right? It's, so you can summarize this in be aggressive in what you test and be very conservative in what you deploy, right? In the HA product, I say our extensive feature checklist is not a checklist for your deployment, right? It's there so that you can choose what you need, not that you enable everything. Because the more complexity you add, the more prone you are to, finding weird configurations, right? So test all the features and then deploy only what you need, right? That's probably the most important question. And with that, there was a lot of things to consider, but don't panic. We're here to help. Okay, and with that, I gladly go back to the questions.
Okay, so to follow up on this question, obviously I can put nodes off-site in my Ceph cluster, and then isn't that PR or is that not recommended?
Okay, so the question is, can you put parts of the Ceph cluster node into different sites, right? So basically running a stretched cluster environment.
Yeah.
You can do that as long as your network latency is so low that it does not negatively impact your performance. And it's a performance thing, and obviously then, if you only have 2 rooms, where you're putting your 3 monitors, how do you divide those up, right? So if you're protecting a gate outage of a data center room, you may actually want to have 3 data center rooms. That comes down to that question. But yes, you can do that, and we have customers doing just that. Okay. One more question, please.
Same way, you told that you need a node number of monitors.
Yes.
Most of the customers only have 2 data centers.
Right.
So how do you fix?
Okay, so the question is how to cope with the fact that most customers only have 2 data centers and are not really prepared for having 3 monitors. That depends. It might be that they have a small server room somewhere where they can put it, or it ends up with them having 2 monitors at one side, which may be what they deem their primary side, and one at the backup side, and if the disaster strikes and the primary side really goes down, they start up a second monitor at the backup side, and then that goes active. They migrate one of the monitors. One of the airports I've worked with have 2 full-fledged data centers where they have, also the storage replicated, and they have a small data room somewhere on that huge airfield where they just have a small service because they have found that multiple cluster solutions actually need this concept of a tiebreaker, right? Because it's not just that Ceph has this problem, it's a mathematical thing, and some customers have started planning for that. So, yeah. Maybe we have time for one more official question. Do we have one more? Otherwise, thank you for your time. It was my pleasure, and enjoy the rest of the conference.